Hi and hello. Welcome to this comprehensive presentation on the current state of industrial hazardous waste management in India. I, Dr. Harshit Sinha, your host, will continue the waste management series. As of today, we will explore the various types of hazardous waste produced, quantify their volumes, and delve into the pressing issues and challenges facing this critical sector up to 2024. Industrial hazardous waste refers to waste that is generated from the industrial activities and poses significant risk to public health and the environment due to its toxic reactivity, flammable, or corrosive property. Managing such waste is a critical for maintaining environmental health and achieving sustainable industrial development. In India, rapid industrialization and the growing manufacturing activities have led to a significant increase in the generation of hazardous waste. Given that hazardous waste includes material like chemical, metals, solvent, and medical waste, improper handling and disposal can lead to a severe pollution, soil contamination, water pollution, and health issues. India being one of the fastest growing economy globally, substantial challenges in addressing the industrial hazardous waste management. The country's legal framework and the institutional arrangement have evolved, but implementation gap and lack of infrastructure persist. This slide discusses about the quantification of industrial hazards waste in India. India's industrial sector has witnessed a significant increase in the hazardous waste generation in recent years. In the fiscal year of 2022, the country produced over 12 million metric tons of hazardous waste, marking a consistent rise since 2019. This upward trend is attributed to rapid industrialization and economic growth. The Central Pollution Control Board, that is CPCB, projects that the annual waste generation in India will escalate to 165 million tons by 2030, with the hazardous waste expected to increase proportionately. Regarding waste management, approximately 47.2% of the hazardous waste is recyclable, while 44.3% is landfillable and 8.5% is incinerable. The CPCB has implemented several measures to manage this growing challenge, including the establishment of 29 common secured landfill facilities across 16 states and 14 common incinerators in 7 states. Despite of these efforts, challenges persist in effectively managing and processing hazardous waste. The increasing volume necessitates the development of more robust waste management infrastructure and the adaptation of sustainable practice to mitigate environmental and the health risk. These figures highlight the significant volume of hazardous waste generated and the diverse management approach required. The high percentage of recyclable waste present opportunities for resource recovery and circular economy activities. Well, this slide discusses about the type of industrial hazardous waste in India. India generates a substantial quantity of industrial hazard waste, much of which is produced by the chemical, pharmaceutical, textile, electronic and the mining industries. According to the Central Pollution Control Board, India generates approximately 7 million tons of hazardous waste annually. This includes a wide range of waste materials such as the industrial chemical, metal, solvent and the waste oil, all of which requires a careful management and disposal to minimize their environmental impact. The Hazardous and Other Waste Management and the Transboundary Movement Rules of 2016, formulated by the Ministry of Environment and the Forest and Climate Change, provide a legal framework for the management of the hazardous waste in India. These rules govern the handling, storage, treatment and disposal of the hazardous waste, ensuring that industries comply with the safety protocol to prevent environmental contamination. The type of hazardous waste produced in India varies significantly depending on the industrial sector. The CPCB classifies hazardous waste into several countries. However, owing to the topic of the current presentation, we discarded electronic e-waste and biomedical waste has already been discussed or supposed to be going to be discussed in our next presentation. So now confined to only different types of industrial hazardous waste with the latest estimate are as follows. First, the chemical waste. It contains approximately 1.2 million tons of hazardous waste annually. This includes waste generated by the industries like petrochemical, pesticides and fertilizer. Chemical waste can include acids, alkalis, solvent and reactive chemical that may pose risks to human health and the environment. The second is related with the metallic waste. Metallic waste, especially from the electronic and mining industry, contributes around 1.3 million tons annually. The mining, metallurgy and electronic industries generate large amount of waste containing metals such as lead, cadmium, mercury and arsenic. These metals are toxic and can contaminate water and soil if not properly handled. The third is related with the solvent. Solvent used in industry such as paints, coating and the cleaning process can become hazardous when disposed of improperly. Common solvent includes acetone, benzene, toluene and xylene. The other is related to the waste oil. The waste oil predominantly from the automotive and machinery sectors contributes nearly 1.5 million tons annually. The automotive machinery and equipment industry generate large quantities of used oil which can be hazardous due to its chemical composition and potential for contamination with heavy metals. The last is related with the sludge. The sludge from the textile and the pharmaceutical industry accounts for about 2 million tons per year. Industrial sludge, particularly from the textile and the pharmaceutical industry, often contains hazardous chemical dyes and solvent. These sludge requires treatment before disposal to avoid pollution. By 2024, India is expected to make significant strides in hazardous waste management. The industry will likely see increased investment in advanced treatment technologies, improved enforcement of regulations, and a shift towards a more circular economy approach in handling hazardous waste. These figures indicate that industrial hazardous waste is a significant challenge for the Indian economy, requiring immediate and effective waste management strategy. The concentration of hazardous waste generation in a few industrialized states highlights the needs of targeted management strategies and infrastructure development in these regions. This slide discusses the classification of industrial waste generation. The industrial hazard waste in India encompasses various forms including solid, liquid, gas and sludge, each posing potential risks to human health and environment. The classification of these wastes is governed by the Hazardous and Other Waste Management and Transboundary Movement Rule of 2016, which categorizes hazardous waste into three primary classes. First, Class A. This class is determined based on the leachable concentration limit, focusing on the potential for the hazardous constituent to leach into the environment. It includes waste containing specific constituent that exceed permissible limits, making them hazardous due to their potential to contaminate soil and the groundwater. Second is Class B. Classification under this category is based on the total threshold limit concentration. Waste in this class constitute that in total concentration exceed defined threshold, indicating a significant risk if not managed properly. Third is Class C. The Class C is based on the hazardous characteristic of the waste such as flammability, corrosivity, reactivity, toxicity, and the other properties that pose direct risk to health and safety. Waste exhibiting in any of these characteristics are deemed hazardous under this classification. Common type of industrial hazardous waste in India includes heavy metal from mining and metal refining industries, organic chemical and petrochemical processes, and various toxic compounds from sectors like pharmaceutical and pesticide. For instance, arsenic and cadmium waste are prevalent in mining and fertilizer industry, while benzene and vinyl chloride are typically in the petrochemicals and the plastic manufacturing. Effective management of these wastes necessitates the proper identification and the classification ensures appropriate handling, treatment, and disposal, thereby mitigating environmental pollution and health hazards. The Central Pollution Control Board provides guidelines and framework to assist industries in the correct classification and management of the hazardous waste, promoting compliance with the national regulations and international standards. This slide discusses about the regulatory framework and the policy initiatives. India's regulatory framework for industrial hazardous waste management has evolved significantly to address environmental and public health concerns. In 1989, introduction of the hazardous waste management and handling rules in the response to the growing industrialization and the associated environmental challenge, the Ministry of Environment and the Forest and Climate Change introduced the Hazardous Waste Management Handling Rule in 1989. These rules aim to regulate the generate, collection, treatment, import, storage, and disposal of hazardous waste, marking India's initial step towards the systematic hazardous waste management. Later, in 2008, amendment to the align with the Basel Convention to align national regulation with the international standard, particularly the Basel Convention on the control of transboundary movement of the hazardous waste and their disposal. The 1989 rule were comprehensively amended in 2008. The revised hazardous waste that is related to the management, handling and the transboundary movement rule of 2008 enhanced the regulation on the import and export of the hazardous waste, ensuring environmentally sound management and minimizing potential risk associated with the transboundary movement. In the year 2016, implementation of the hazardous and other waste management and transboundary movement rule established by the India's Ministry of Environment, Forest and the Climate Change provide a comprehensive framework for the management of the hazardous and other waste. These rules emphasize waste minimization, safe handling, and environmentally sound disposal aligned with the international convention like the Basel Convention. Since their inception, several amendments have been introduced to enhance their effectiveness. The first amendment was done in July 6, 2016, shortly after the original notification. This amendment addresses initial implementation challenges and refined definitions and streamlined procedure to facilitate compliance. The second amendment was done in February 28, 2017. This revision further clarified regulatory provision, ensuring better alignment with the industry practice and environmental safeguard. The third amendment was done in 11 June 2018, aimed at improving operational efficiency. This amendment introduced measures to simplify authorization process and enhance monitoring mechanism. Thereafter, the fourth amendment was done in 1st March 2019, focusing on the ease of doing business. This update streamlined compliance requirements, reducing procedural bottleneck while maintaining environmental protection. Thereafter, the fifth amendment was done in 9th October 2020. In response to the evolving industry dynamic, this amendment incorporated provisions for emerging waste streams, ensuring comprehensive regulatory coverage. Next, the sixth amendment was done in 12th November 2021. This update reinforced extended producer responsibility, that is EPR framework, holding producer accountable for the life cycle management of their product. Next was the seventh amendment was done in 21st July 2022, introducing EPR for the waste tires. This amendment mandates producer to establish mechanism for the collection and recycling of the end-of-life tires. Thereafter, the 8th Amendment came in 2023, that is September 18. Focusing on the used oil, this revision implement EPR obligation for producer, ensuring environmentally sound and collection and recycling process. And thereafter, the last till March 12, 2024 amendment came. The latest amendment introduced the concept of deposition centers for hazardous waste, requires these centers to obtain authorization from the State Pollution Control Board, thereby strengthening waste collection infrastructure. These progressive amendments reflects India's commitment to enhance hazardous waste management, balancing industrial growth with the environmental sustainability and alignment with the global best practices. Now let us discuss the regional distribution of the hazardous waste generation. Industrial hazardous waste generation in India exhibits significant regional disparity, with the certain states contributing disproportionately to the national total. According to the Central Pollution Control Board 2022-2023 inventory, the country generated approximately 15.66 million metric tons of hazardous waste during that period. Gujarat emerged as the largest contributor, accounting for over 4.2 million metric tons, representing nearly than one-third of the national hazardous waste output. This is followed up by the Maharashtra, closely with the substantial share of the total hazardous waste generated. Then Andhra Pradesh also featured among the top contributors with a significant percentage of national total. The remaining states collectively accounted for the balance of the hazardous waste generation, highlighting the widespread nature of the industrial activities across the country. This regional distribution underscores the concentration of the industrial activities in the western and the southern India, particularly in the states like Gujarat and Maharashtra, which are industrial powerhouses with a diverse manufacturing sector. The substantial hazardous waste generation in these regions necessitate robust waste management infrastructure and stringent regulatory oversight to mitigate environmental and public health risk. Now let us discuss environment and health impact of improper management of these waste management. Improper management of industrial hazard waste in India leads to significant environmental degradation and poses serious health risks. First is related with the soil contamination. Inadequate disposal practice result in a hazardous chemical seeping into the soil, rendering it infertility and disrupting agriculture productivity. The contamination can lead to accumulation of the toxic substance in the food chain, adversely affecting human health. The second is related with the water pollution. The hazardous waste leachates infiltrates groundwater and surface water source, introducing toxic substance that comprises drinking water quality and aquatic ecosystems. Contaminated water source can lead to diseases such as cholera, dysentery among the local population. The next is related with the air pollution. Open burning of improper incinerators of hazardous waste releases toxic gas and particularly matters into the atmosphere, contributing to air quality deterioration. Exposure to polluted air can cause respiratory issues, cardiovascular diseases, and other serious health conditions. Next is related to ecosystem destruction. The release of hazardous substance into the environmental can lead to destruction of the habitat, loss of biodiversity, and destruction of the ecological balance. This degradation affects not only the wildlife but also the livelihoods of communities dependent on the natural resources. And the last is related to the human health risk. Population residing near improperly managed hazardous waste sites are at increased risk of chronic health conditions including cancer, neurological disorder, and reproductive issues. Studies have shown a correlation between the proximity to hazardous waste sites and an adverse health outcome. Addressing these challenges requires a stringent enforcement of the waste management regulation, public awareness initiatives, and the adoption of the sustainable industrial practice to mitigate the detrimental impact on both the environmental and the human health. Improper management of hazardous waste can lead to severe environmental degradation and pose significant risk to human health. Long-term exposure to hazardous substance can also in chronic health condition, genetic mutation and ecological imbalances. This slide discusses about the challenges in the industrial hazard waste management. Industrial hazard waste management in India faces several significant challenges that hinders effective environmental protection and public health safety. First is related to infrastructure gaps. The country lacks adequate facilities for the treatment, storage and disposal of hazardous waste. Many regions do not have access to power waste management system, leading to the accumulation of untreated hazardous material. This deficiency results in environmental contamination and poses health risks to nearby communities. The next is related to the technological limitation. The adoption of the advanced waste treatment technologies is limited. Many industries continue to rely on the outdated methods that are inefficiently environmentally harmful. The lack of access to modern technology impedes the safe and effective processing of the hazardous waste, exacerbating pollution issues. The third is related to the compliance issues. Enforcement of the hazardous waste management regulation is inconsistent. Some industries evade compliance due to weak regulatory oversight, leading to improper disposal practice. This non-compliance undermines the environmental law and contributes to widespread pollution. Skill gaps. There is a shortage of a trained professional in field of hazardous waste management. The skill gap results in improper handling and disposal of hazardous materials, increasing the risk of environmental contamination and health hazards. Addressing these challenges requires a multifaceted approach, including the investment in infrastructure, adoption of advanced technology, stringent enforcement of regulations, and development of a specialized training program to build a skilled workforce capable of managing hazardous waste effectively. This slide discusses about the innovative approaches in hazardous waste management. India is adopting innovative approaches to enhance the industrial hazardous waste management, focusing on minimizing the environmental impact and promoting sustainability. The first is related to the waste minimization and resource recovery. Industries are implementing strategies to reduce hazardous waste generation at source. This includes process optimization, material substitution, and adopting cleaner production technique. Additionally, resource recovery initiatives such as recycling and reusing waste material are being emphasized to convert waste into valuable resources. The next is related with the advanced treatment technology. The adoption of cutting-edge technology like plasma gasification is being explored to treat hazardous waste effectively. Plasma gasification converts waste into synthesized gas, cyanic gas, which can be used for energy production, thereby reducing the volume of the waste and generating energy simultaneously. The third is related with the geographical information system based monitoring. The Ministry of Environment, Forest and Climate Change has initiated GIS-based National Hazardous Waste Information System. This web-based system facilitates real-time monitoring and management of the hazardous waste across the country, enhancing the regulatory oversight and ensuring the compliance. The next is related with the public-private partnership. Collaboration between the government agencies and the private sector entities are being encouraged to develop and operate hazardous waste treatment and disposal facilities. These partnerships aim to leverage private sector efficiency and investment to build robust waste management infrastructure. And the last but not the least is related with the capacity building and the training. Efforts are underway to bridge the skill gap in hazardous waste management through specialized training programs. These programs aims to equip professionals with the necessary expertise to handle, treat and dispose of the hazardous waste safely and effectively. These innovative approaches reflects India's commitment to improve hazardous waste management practice, ensuring environmental sustainability and safeguard public health. These cutting-edge technology represents the future of hazardous waste management in India, offering more efficient, safer and environmentally friendly solution to tackle the growing challenges in the sector. Well, this slide discusses about the international cooperation and the best practices. India actively engaged in international cooperation to enhance its hazardous waste management practice aligned with the global standards and be benefiting from the shared expertise. The first is related with the Basel Convention. As a party to the Basel Convention, India is committed to controlling transboundary movement of hazardous waste and ensuring their environmentally sound management. The Basel Convention Regional Center plays a pivot role in this regards, offering capacity building and technology transfer services to assist countries in implementing the convention provision. These centers facilitate training, workshops, and technical assistance, enabling India to stay abreast of the best practices in hazardous waste management. Next is related with the technology transfer. Though its involvement with the Basel Convention, India has access to framework of the technology transfer aimed at promoting the adoption of the cleaner production methods and advanced waste treatment technologies. This framework encourages collaboration between developed and developing countries, facilitating the sharing of innovative solutions to manage hazardous waste effectively. The next is related with the capacity building. The Stockholm Convention Regional Center for Capacity Building and the Transfer of Technology, located in Nagpur, India, serve as a hub for enhancing the national capability in managing hazardous substances. The center offers training program, technical assistance and disseminate information on the best practices, thereby strengthening India's institutional framework for hazardous waste management. And the last but not the least is related with the research partnership. India's collaboration with international organizations and participation in global projects facilitate the exchange of the knowledge and the development of the innovative waste management strategy. For instance, the Basel Convention has supported projects in Asia-Pacific region, including India, focusing on the environmentally sound management of e-waste. These initiatives promote partnership among the government, industry and civil society to address hazardous waste challenges through research and development. By engaging in these international frames and leveraging the global expertise, India strives to improve its hazardous waste management system, ensuring environmentally sustainable and public health protection. Well, this slide discusses case study of Gujarat, a model state for hazardous waste management. Why this state has been considered as a model state? Let us look at it. Gujarat has emerged as a model state in India for hazardous waste management, demonstrating a comprehensive approach encompassing policy formulation, infrastructure development, technological integration and robust monitoring mechanism. The first is related to the policy formulation and implementation. The Gujarat Pollution Control Board enforces environmental regulation including the hazardous waste management, handling and transboundary movement of Rule 2008. These rules mandate the industries to obtain authorization of hazardous waste management, ensuring compliance with the national standard. The next is related with the infrastructure development. Gujarat has established extensive infrastructure to manage hazardous waste effectively. The state boasts multiple common hazardous waste treatment, storage and disposal facilities, that is TSDFs, which provides centralized location for the safe treatment and disposal of the hazardous waste. Additionally, the development of the common effluent treatment plant aids in treating industrial effluent reducing environmental pollution. The third is related with the technological integration. The state has adopted advanced technologies to enhance waste management practice. The implementation of extended green node, that is XGN, software facilities, real-time monitoring and transparency in the environmental compliance. This e-governance initiative enable efficient communication between the industries and the regulatory authorities, streamlining the consent and the compliance process. The next is related with the monitoring and evaluation, that is the compliance, monitoring compliance. The GPCP conducts a regular monitoring of air and water quality to assess the pollution level across the state. The establishment of the regional office and the laboratories equipped with the modern analytical instruments ensures accurate assessment of environmental parameters. Furthermore, the use of geographical information system technology aids in mapping pollution source and implementing the target intervention. The next is most important is related with the pollution index. Gujarat had developed a pollution index to categorize the industries based on their pollution potential. This index assists in prioritizing the regulatory action and resource allocation for environmental management. Industries are classified into red, orange and green categories, with red indicating high pollution potential. This categorization enables focused monitoring and implementation of pollution control measures. Through a synergetic approach involving stringent policy enforcement, infrastructure development, technology advancement and continuous monitoring, Gujarat has set a benchmark in hazardous waste management. The state proactive measures have not only mitigated environmental pollution but also promoted sustainable industrial growth, serving as replicable model for the other regions in the country. Now let us see what are the future outlook or the industrial hazardous waste projections for 2024. By 2024, India is expected to make significant strides in hazardous waste management. The industry will likely see increase in investment in advanced treatment technology, improve enforcement of regulation and shift towards a more circular economy approach in handling hazardous waste. India is poised to make significant advancement in hazardous waste management by 2024, focusing on increased waste generation, enhanced recycling capacity, expanded infrastructure and waste reduction strategy. The first is related to projected annual hazardous waste generation. That is, by 2024, India's annual hazardous waste generation is expected to reach approximately 9.5 million metric tons, marking a substantial increase from the current level. This rise is attributed to rapid industrialization and economic growth, necessitating robust waste management system to handle the escalating volume. The target recycling rate. The country aims to evaluate its hazardous waste recycling rate to 60% by 2024, up from the current rate of 49.3%. This ambitious target reflects a commitment to improve resource recovery and sustainable waste management practice. Achieving this goal will require the implementation of efficient recycling technologies and strengthening of regulatory framework to ensure compliance. The next is related to expansion of the treatment, storage and disposal facilities, that is the TSDFs. To address existing infrastructure gap, India plans to increase the number of operational TSDF to 70 by 2024. This expansion is crucial for the safe and effective management of hazardous waste, providing facilities for its treatment, storage and disposal in an environmentally sound manner. And the last is, I think, related to the hazardous waste generation reduction target. In the line with the global sustainability efforts, India has set a target to reduce hazardous waste generation by 25% through the adoption of the cleaner production technology and processes optimization. This initiative emphasizes the importance of pollution prevention as the source, encouraging industries to implement eco-friendly practice and enhance operational efficiency. Collectively, these projections and targets underscore India's proactive approach to hazardous waste management by focusing on increased recycling rates, expanding infrastructure, and promoting waste reduction strategies. The country aims to mitigate the environmental and health impact associated with the hazardous waste. The successful realization of these objectives will depend on coordinated efforts among the government agencies, industries, and the public to foster and culture the sustainability of environmentally responsibility. Here we end up the presentation and now recall what we have covered in the today's presentation. We started with the introduction of the industrial hazardous waste generation as a constant challenge in India, followed by quantification, types, and classification of industrial hazardous waste and its generation in India. Further, how regulatory framework and policy initiative evolved with the hazardous waste generation and narrated its regional distribution with environmental and health impact on the improper waste management. Continuing the topic, we explore the related challenges and innovative approaches in industrial hazardous waste management. Later describe the international cooperation on best practices, followed up with the case study of Gujarat, a model state for hazardous waste management. At the end, we explore future outlook projections of the industrial hazard waste management in India for 2024. In the next presentation, we will discuss the most neglected topic and the least preferred topic on the waste management. So stay tuned till next week before we dive into the next topic on biomedical waste, the most demanding and challenging waste management in India. Till then, we wish you season greetings and happy and prosperous year 2025.